Jam Pass question 2001, question number 46. The force on a current carrying conductor in a magnetic field is greatest when the dash A. Conductor makes an angle of 60 degrees with the field. Force is independent of the angle between the field and the conductor. Conductor is parallel with the field. D. Conductor is at right angles with the field. Our question today is centered on electromagnetism. Electromagnetism, combination of electricity and magnetism. The first aspect of electromagnetism was converting electricity to magnetism, and the second aspect is the other way, converting magnetism back to electricity. So this is the first aspect, discovered by Professor Hans Christian Ørsted, a university professor. He was teaching some undergraduate students and made a discovery that anytime his circuit is turned on, that the wires in the circuit, they change from being ordinary wires to becoming magnets. Magnets. That's what I mean by electromagnetism in the first aspect. Electricity causing magnetism. Okay, in a very simple illustration, if we have a current carrying conductor, okay, let's start this way first. At this point, this is just a conductor, no current in it. It's just a conductor with no current in it, but it has atoms and charges within. At this point, we call this branch of electricity electromagnetism. At this point, we call this electrostatics. Electrostatics. Why? Because the electrons in this conductor or this material, they are static. They are not flowing. They are not yet currents. They are not flowing with respect to time at this moment because there is no force to push them. So at this point, it is electrostatics. Electrostatics do not cause magnetism. What causes magnetism is electrodynamics. Then let's introduce dynamics. See what happens. This time I have energy source. Let's say I have EMF. Then I will now connect to this. Connect to that. This is my EMF. So the game has said this is now electrodynamics. Why? We now have source of energy pushing those charges or electrons that are now flowing. Okay, let's take it this way. Let's consider electron flow. So current is going in this direction. Then Hans Christian Ørsted discovered that anytime we have electrodynamics, when charges begin to flow in a conductor, that the conductor name changes to becoming current carrying conductor. It's not carrying current, or otherwise a magnet or electromagnet. So this is now a magnet. It now starts having what we call magnetic effect. If I should have tiny pieces of iron here, or what we call iron filings, this my conductor will magnetize most of them, depending on the proximity, the distance. So this is no more an ordinary conductor, it is now a magnet. So take note, every current carrying conductor or a live wire, any wire that has life in it is a current carrying conductor. It's also a magnet, or better called electromagnet or temporal magnet, depending on when the current is turned on or turned off, temporal or electromagnets. Okay, then when Hans Christian Ørsted made this discovery, he had to publish the idea. He published the idea. So when he published this idea, it was a wow to the community of scientists. A scholar by name Mare Andre Ampe encountered this publication and had to deploy more time and energy to the project. So Mare Andre Ampe came up with new discovery about this effect. What did he discover? He noticed that Hans Christian Ørsted is yet to tell us the full interaction between electricity and magnetism. So Mare discovered that the magnetism coming out from this current carrying conductor comes out in a certain pattern, and that pattern was, or the pattern X, because it's still facts. The pattern is this way: that the current carrying conductor will emanate magnetic field at angle 90 degrees to the current carrying conductor. So that magnetic force or the field coming out from the conductor marks angle 90 degrees with the current carrying conductor itself. Okay, then notice, this is the current direction, then the field will come out from it both ways at angle of 90 degrees, either perpendicular at right angles or 90 degrees. They are all the same. So this is our field, symbolized with B, capital B. Capital B indicating magnetic field. Magnetic field. YI indicating current. So a current carrying conductor will give you the maximum force at angle 90 degrees. Then if I should have anything here, that thing can easily interact with the magnetic field because it's at angle 90 degrees to it. Then any other conductor that is outside 90 degrees, let's compare two conductors here, conductor A and conductor B. The one that will experience the maximum force is A, because A is within the magnetic field. So the magnetic force will interact most with it. So any other thing less than 90 will experience less force. Then anything this way, parallel, will experience zero force. Because we measure from here. We measure our angle from here. So 90 is maximum. Then this way, on the same level with the conductor, you experience the minimum force. Minimum, because you are hiding away from the magnetic force that comes with the magnetic field. Okay, that is why, observe in our neighborhoods, we have current carrying conductors in this pattern. We have current carrying conductors this way, about 3 of them. The currents are going in the same direction. Now you notice something like stick. You used to separate them. Something like a stick. It's because of a reason. Let's see the reason. So what happens is that these are current carrying conductors. The field will emanate this way. The field emanates this way. Magnetic field has 2 poles, north, south. Because they're going in the same direction, you maintain the same pattern. North, south, north, south. Notice we have unlike poles. And what will happen? They will attract. So to avoid that attraction, we work on the safety gap, on the mean distance between the 3 of them. We work on it, and also put a stick, because we are very much aware of natural forces like force of wind and any other force that can tamper the distance. So that's why I have something like a separation, something sticking them together to avoid that, to avoid forces of nature, reducing the distance and causing attraction of those live wires. So observe, somehow the magnetic fields interfere, and that brings about maximum interaction. 90 degrees, 90 degrees, 90 degrees. So when our field is at angle 90 degrees with the current carrying conductor, there is maximum force. Mathematically, remember, physics is further explained in the language of mathematics. To make it simple, what we've said now is summarized as magnetic force is equal to QVB sine theta. This is a popular formula in electromagnetism. Also the same thing as FB, that magnetic force, B, that's the okay, with time I'll tell you what the parameters stand for, sine theta again. Where Q stands for charge, V indicating motion, that the charge must move. Before this force will exist, before the force will coexist from a conductor, the charges in the conductor must do what? Move. That's why we have speed. Then it will now bring about magnetic field. Then sine theta. Sine theta tells you that angle determines the amount of force you experience. And they are saying that the angle that will give you the most force is 90 degrees. Sine 90 is 1. The sine of every other angle less than 90 is less than 1. That's why that 1 is what will give you the maximum force. Anything less than 1 is decimal, 0 point. That will be reducing the force. So to get the maximum force, 90 degrees. The same thing here. Here we have to do some manipulations. It's the same field, magnetic field. This time is length of the wire and what? Current. These two formulas are the same. Just careful manipulations. With time we'll show how the manipulation was done. But they are the same. It indicates the idea that is being favored today, that is being favored in today's question. The summary is, the maximum force is at angle 90 degrees. And what's that 90 degrees? 90 degrees is the angle made between a current carrying conductor and the magnetic field emanating from that current carrying conductor. So that is how nature permits the interaction between electricity and magnetism. Please stay tuned as we push ahead. Thank you.